So good morning all of you. So today our topic is Newton-Raphson method or method of tangents or Newton iterative method. So how to finding the numerical solution of algebraic equations or transcendental equations. So what is the procedure in this method? First of all, see that here. So assumption, the given differential equation is f of x is equal to 0. Okay, this is any equation, transcendental equation or algebraic equation. So in this method, how to finding the solution? So that is, so the solution is lies between any interval. Which interval? The function value, for example, interval a comma b, that is f of a and f of b have opposite signs. Yes, must be using intermediate value theorem. That is the most important theorem. Using that theorem, you have to finding the root. That is a solution. So let f of x be continuous function in the interval a comma b, and f of a and f of b have opposite signs. So first of all, in this method, assumption the initial value x naught. So now let x naught be initial approximate root of the given equation 1. So then the Newton-Raphson method formula is given by, this is xn is equal to xn minus 1 minus f of xn minus 1 by f dash of xn minus 1, where n is equal to 1, 2, 3 up to so on. So n is equal to 1, substitute the first approximation value using initial. Okay, now substituting here. Next n is equal to substitute second approximation. Next n is equal to 3, third approximation, up to so on. We have to finding the approximation solutions. So any two consecutive approximations are equal, then that is a required root of the given equation. So that is a value, that is a solution, that is a required value. So now here this is formula is called Newton's-Raphson formula. So again now your note. So how to choosing the initial value may be given or not given in the question. If the given, no problem. If not given initial value, how to write initial value. That is, if initial approximation x naught is not given in the problem, then let x naught is equal to a or x naught is equal to b. That means given interval, children, a b interval, f of a finding, f of b finding, and which value is near to 0. If f of b is near to 0, then a is initial value x naught. If f of b is near to 0, then b is the initial value. So that is initial approximation finding. Okay, understood? Okay, is that clear? Yeah, okay. Okay, now go to the problems here. Yeah, see our first problem here. Find the real root of the equation x cube minus 2x minus 5 is equal to 0. Correct 3 decimal places by Newton-Raphson method. Okay, now first of all, the given assumption the function is f of x is equal to x cube minus 2x minus 5 is equal to 0, and f dash of x is equal to 3x square minus 1. The differentiation of this function, x cube 3x square minus 2. So now choosing the values, finding the real root, we can do finding negative or positive. Now positive is the first of all. Okay, no, not only negative, we can finding any root, but always we have to finding to write positive. Okay, Yeah, first assumption 0 substitute. F of 0 is equal to. That means by substituting the positive value starting 0 to start. So now finding the interval a comma b such that f of a and f of b have opposite signs. First substituting in the function x is equal to 0. That is 0 cube minus 2 into 0 minus 5 is equal to minus 5. Then negative. So next file choosing f of 1. So f of 1 is equal also 1 cube minus 2 into 1 minus 5 is equal to minus 6. This is also negative. So next one f of 2. So f of 2 means substituting 2 cube minus 2 into 2 minus 5 is equal to minus 1 is less than 0. So next one is substituting f of 2.5. So 2.5 whole cube minus 2 into 2.5 minus 5 is equal to 5.625. Observe చేయండి ఇక్కడ consecutive values. 2 into 2.5 have opposite signs. F of 2 is a minus, f of 2.5 is a positive. Okay, now? So the root is lies between 2 and 2.5. So that is product of f of 2 into f of 2.5 is less than 0. Then the root is lies between 2 and 2.5. Okay, now a is equal to 2, b is equal to 2.5. Okay. Yeah. And now finding initial value. So f of 2 is equal to minus 1. So which is near to 0. F of 2 is minus 1. F of 2.5 is a 5. The 5 is a larger. But here f of 2 minus 5 is a near to 0. Therefore, initial value 2. So then initial approximation to the root x is equal to 2. So now using the Newton-Raphson formula. By Newton-Raphson formula is, this is Newton-Raphson formula. Xn is equal to xn minus 1 minus f of xn minus 1 by f dash of xn minus 1, where n is equal to 1, 2, 3. Okay, now first substituting n is equal to 1, we're getting the first approximations. Okay, now? Here now continuation, that is equal to here. N is equal to 1 substituting in the formula. The first approximation to the root is x1 is equal to x naught minus f of x naught by f dash of x naught. So initial value x naught 2 substituting here. So that is 2 minus f of 2 by f dash of 2. Okay. That is equal to here. The value is 2 minus, so f of 2 already finding by f dash of 2. F dash of 2 means already finding f dash of x. Okay, now f dash of x substituting x is equal to, we're getting the value. Simplification. So 2.1. This is first approximation. Okay, now? So similarly, second approximation in the above formula, substituting n is equal to. That is, n is equal to substitute. The formula is x2 is equal to x1 minus f of x1 by f dash of x1. So x1 was substituting here. Same procedure. So 2.1 minus f of 2.1 by f dash of 2.1. So that is equal to 2.1 minus f of 2.1 means the given function f of x is equal to here. In that one substituting x is equal to 2.1, simplification getting 0.061. So similarly f dash of 2.1 already finding f dash of x, in that one substituting 2.1 we getting 11.2523. Here that is simplification. This is second approximation value, x2 is equal to 2.0945681. Okay, now next finding third approximation. Put n is equal to third approximation to the root. The formula is x3 is equal to x2 minus f of x2 by f dash of x2. Now using x2 by substituting. Okay, that is equal to x2 2.0945681 minus f of, that is same f of x substituting x value, here f dash of x is equal to substituting. So that is equal simplification. Yeah, x3 is equal to 2.0945514. So now we are observing, see that second and third approximations, x2, x3 are same up to 4 decimal places. In the question up to 3 decimal places, so already is clear. So second, third approximation nearly same. Okay, now so that is the required root. Hence the required root is x is equal to x3 2.0945514. This is the approximation root to the given equation. Okay, this is a Newton-Raphson method. Okay, understood? Okay. Yeah, see the next problem. Find the real root of x plus log x base 10 minus 2 is equal to 0 near to 1.8 by Newton-Raphson method. So in this method, in this problem already given the initial value 1.8. This is x naught. Okay, now finding the remaining root. Okay, the fixed numerical value. So assumption f of x is equal to x plus log x base 10 minus 2 is equal to 0, and which is differentiation. F dash of x is equal to 1 plus rate of log x 1 by x. Okay, now. So now given initial value is x naught is equal to 1.8. So now using Newton-Raphson formula, this is Newton-Raphson formula, first substituting n is equal to 1. N is equal to 1, first approximation to the root is x1 is equal to x naught minus f of x naught by f dash of x naught. Okay, substituting here 1.8 minus f of 1.8 by f dash of 1.8. So f of 1.8 means here substituting f of x, and f dash of 1 point means here f dash of x substituting here. Okay, now simplification here 1.8 minus this simplification we are getting. This is f of 1.8. This is f of 1.8. F dash of 1.8. So this is first approximation. X1 is equal to 1.76446. Okay. Yeah. Next continuation, finding second approximation. Yeah. Put n is equal to second approximation to the root. X2 is equal to x1 minus f of x1 by f dash of x1. Substituting x1 value. Okay, in this formula. Similarly, you have to finding simplification. This is f of x1 value. This is f dash of x1 value. Substituting the given equation f of x and f dash of x. Simplification here we are getting x2 value. This is x2 second approximation 1.75739. Similarly, third approximation x3 is equal to x2 minus f of x2 by f dash of x2. Substituting x2 value here. So x2 here, this is f of x2, f of f dash of x2. Simplification, x3, third approximation 1.75595. Yeah, we see that second and third approximation that is same up to 2 decimal places. Okay, up to 2 decimal places, enough, no problem. So up to 2 decimal places, the x2, x3 is the equal. So there is a choosing the required root. So the required root is x is equal to x3 1.75595. Okay, is it clear? Understood? Yeah. See the next problem here. One problem. Find the Newton-Raphson formula to find the reciprocal of a positive number. Hence, find 1 by 18. And then, but how to finding the reciprocal of a positive number? So that is 1 by something, a real number. That is reciprocal here. For example, k is a positive number. You have to choosing k, any positive number. Now, to finding 1 by k. Finding 1 by k, it's a Newton-Raphson formula. From using that formula, you have to finding 1 by 18. So first of all, finding the formula, let assumption 1 by k is a reciprocal of a positive number k. That is assumption x is equal to 1 by k. So this equation can be write in the function form. That is f of x is equal 0. That is equal, which is can be write 1 by x minus k is equal 0. So assumption this is f of x. Okay. So that let f of x is equal to 1 by x minus k is equal to 0. Okay. Now finding differentiation, f dash of x is equal to minus 1 by x square. Okay. So now using the formula, Newton-Raphson formula, that is Newton-Raphson formula, in this formula substituting here, xn is equal to xn minus 1 minus, so f of xn minus 1 means this is f of x. Okay, x place low, xn minus 1 replace chain, that is 1 by xn minus 1 minus k by, this is f dash of x, and f dash of x place low, xn minus 1, this is f dash of x minus 1 by xn minus 1 whole square. Simplification here, xn minus 1 plus xn minus 1 minus k into xn minus 1 whole square. So that is common here. Xn minus 1 common. Both are same. 2 minus k into xn minus 1 with n is equal to 1, 2, 3. So this is a Newton-Raphson formula for finding reciprocal of a positive number. So k is equal to any positive number substituting here. We have to requiring value. Substituting n is equal to 1, 2, this is approximation. Any two consecutive approximations are equal, that is required value. Okay, na? So this is the iterative Newton-Raphson formula to find the reciprocal of a positive number. So that is now finding the given reduction. Reduce the value to finding 1 by 18. So k is equal to 18 here. That is x is equal to 1 by 18. So let the initial approximation to the value 1 by 18. So now choosing the initial value is near to 1 by 18. The 1 by 8 is perfect reciprocal. Which value? 20. That is 1 by 20 is the perfect reciprocal. Assumption x naught is equal to 1 by 20 is equal to 0.05. Okay, now using this formula from equation 1. So that is substituting first n is equal to 1. X1 is equal to x naught minus 2 minus 18 x naught. That is equal to x naught value 0.05. 2 minus 18 into x naught 0.05. Simplification here 0.055. The first approximation. Second approximation, x2 is equal to x1 minus 2 into 18 x1 is equal to 0.055 into 2 minus 18 into 0.55. Okay, now simplification we are getting 0.0555. Third approximation similarly same, we getting 0.0555. So up to so on, we getting the same 0.05555 up to so on. So that is the required value. Hence, the required value is x is equal to 1 by 18 is equal to 0.05555 up to so on approximation. So this is the using Newton's-Raphson formula, we have to finding a reciprocal of a positive number. Okay, is it clear? Understood all of you? Okay, this is the Newton-Raphson method and with example. Okay. Okay. Now this is the Newton-Raphson method. Now class is over. Thank you all. Thank you for watching this video. Thank you.